Now here we're going to look at geometric patterns and see what's going on and describe the next steps. So first of all, if I look in step 1, I notice I have a 1 plus 1 or 1 by 1 square and then plus 4 outside squares. So if I look here how to relate step 1 to the pattern, I would have the step number squared, 1 squared, plus 4 of the outside squareds, and that would give me a total of 5. So if you notice for step 2, I have a 2 by 2 square, so I have 2 squared, and then I have the 4 on the outside, so then I add 4. And 2 squared, 4, plus another 4, gives me a total of 8. So for the third one, I have a 3 by 3 squared, or 3 squared. If you notice, I'm taking the step number, squaring it, and then adding the 4 outside squared. So 3 squared is 9 plus 4, and 9 plus 4 gives me a total of 13. So if I have to do step 5, I know on the inside I'm going to have a 5 by 5 square and 4 outside square. So I'm going to have a 5 by 5 square, and I have plus 4 on the outside. So to describe step 18, we have an 18 by 18 square, and I add 4 on the outside. So to describe how many are in there for step 5, if we do that, we would have 5 squared, 5 times 5, plus 4. And then 5 times 5 gives us 25, plus 4 would give us 29 squares in step 5. So step 18, we could write that as 18 squared plus 4, or just 18 times 18 plus 4. But I, 100% for sure, would use a calculator for that. So you can go 18 times 18 plus 4. And that would give us 328 squares. Otherwise, you can also go 18 and then use this button to the second power plus 4. And it's a different way to get the same answer. So now to write an equation to represent the relationships between the step number and the number of squares. So here, let's say we had step number n. What I do know is the square on the inside would have length n, and then by n. And then I would have another 4 on the outside. So in general, if I wanted that relationship, I would take n times n, or n squared, and then add the 4 squares on the outside. So again, this represents the n by n square in the middle. And this 4 represents the 4 outside squares. So now, if we had to represent the first 3 patterns that were n squared minus 1. So if we did step 1, step 1 would give us 1 squared minus 1. So it would be empty. There would be nothing in step 1. So step 2, if I did that calculation, we would have 2 times 2, but minus 1, or 4 minus 1, which is 3. So we would have a 2 by 2 square, but we're going to take away one of the squares. So it would look like this. You would have the 2 by 2 square, but you're missing one of the squares. So you'd have 4 minus 1, which is 3. And for step 3, you would have your 3 by 3 square minus 1, or 9 minus 1. And what I'm going to do here is draw in the 6 pieces and then take one piece out of the corner there.